Hi everyone. This series of videos will take you through lesson 8D, which is page 7 in the new packet, and that's an extension of what we did in the previous lesson with exponents, and now starting to solve equations with those exponents. So the first thing that we're going to do in question number 1 is just think about what we know about exponents, and not try to complicate things too much, but instead just try to tap into our existing instincts about how exponents work. For example, in question number 1 it says, consider the equation x cubed equals negative 8. So when we want to think about which value of x would satisfy this equation, let's just think intuitively about what this equation is saying. It's saying that something cubed, or something times itself 3 times, would give us negative 8 as an answer. So if we think logically, we would just have to think for a second about what number would multiply itself, and then itself, and then itself, to get negative 8. And naturally, if you've already started to think about this, you could probably tell that negative 2 would work, because negative 2 times negative 2 is positive 4, and positive 4 times negative 2 would be negative 8. So of course, negative 2 is the value of x that would satisfy the equation. And of course, in letter B, you can prove to yourself, however you want to write it, that the value of x you chose is going to work. You can show that negative 2 times negative 2 times negative 2 is indeed negative 8. You don't have to do anything too fancy there. But letter C is saying, hey, what if we didn't want to just guess? I mean, we got lucky that negative 8 was a pretty small number, and that we could think about a really nice, easy answer like negative 2, but what if the number was big, or a decimal, or something really weird? Like, would we be so lucky to assume that we can always just guess the correct answer right off the bat? What if we had to do it with real algebra? How could we do this? So, this equation can be solved algebraically, using actual methods of algebra like opposites and stuff. And there are really 2 different ways that we can think about it. I'm going to show both ways in the hopes that both ways will make sense. Now I'm going to show both ways in different videos because I want to make sure that what I'm doing in each separate method makes sense, since ultimately by the end of this lesson you're going to end up forming a preference in all logic between one method or the other, and your preference is probably going to dictate how you do questions like number 4. So the reason why I want to make sure that I go through each method separately is so you can compare and contrast both methods. You can ask yourself which way made more sense to you, which way would you see yourself doing the problem logically, and which way do you see yourself remembering, so that way moving forward you have a method that you can feel pretty confident that you understand. It's not going to be necessary to do every problem with both methods, so this is just flexibility. You'll see both methods, but you'll only be expected to pick the one that makes the most sense to you. So that flexibility should be kind of nice. Now, the method that I'll talk about in this video is called using radicals. So what I want to do is just make sure that I first understand what the word radical means. The radical is really what we've been calling a root for all these years. And you'll remember from the previous lesson, I'm not calling them square roots anymore because we know now not every root is a square root. A square root is really only if you have a multiplication twice. If I want to use other types of roots, like a cube root that counts for 3 multiplications, or a 4th root that counts for 4 multiplications, or a 5th root that counts for 5 multiplications, I can't use the word square in those contexts. So the word root or radical is just a generic way of saying, hey, you're going to be thinking about some repeated multiplications. Now, if I'm going to use this symbol as part of my solution process, I should definitely think about how that's going to come in. I'm going to recopy the first equation that they gave us, x cubed equals negative 8, and I'm going to ask myself, how would a radical help me here? Now, if we think about it, x is the part that we want to get by itself. So naturally, if I want to get rid of the cube to do the algebra that I know we typically do, we want to get rid of whatever's near x, I have to ask myself, what's the opposite of a cube? The opposite is what cancels something out so that x can be by itself. And the opposite of a cube is a cube root. Just like the opposite of a square is a square root, many of us know that, the opposite of a cube is a cube root. And a cube root is what we write like this, the third root with a little radical symbol. Now, you'll notice I just introduced that third root into the problem on the left-hand side. That's brand new to the problem. And we know when we do algebra, we can't just put something new on the left. We have to do that new thing on both sides of the problem, because that's how algebra works. Whatever we're doing to one side, we have to do to the other. So you'll notice I introduced a cube root into the problem. The reason I did that is because the cube root is going to cancel the cube on the left-hand side. The cube root cancels the cube. In case you're looking at that going, wait, why? I don't understand. Why does it do that? You could actually think about what we did in the previous lesson. Remember how the cube root of x cubed can be written as a fraction? That could be x to the power of 3 over 3. Well, 3 over 3 cancels out. 3 over 3 is just 1, and x to the power of 1 is just x. So that's why technically the cube and the cube root do cancel each other out. It's because as a fraction you're getting 3 over 3, which is 1. 1 is not a necessary power to write. X to the power of 1 is just x, thus x really is by itself. That's the beauty of using a radical, is that you can effectively cancel out a power, and the root and the power are opposites of each other. You already know that with square roots. The square root is the opposite of the square power. So now we're realizing that any root, anything that looks like a cube root, fourth root, fifth root, sixth root, whatever, is just the opposite of its equivalent power. Third root is the opposite of a third power. Fourth root is the opposite of a fourth power. Fifth root is the opposite of a fifth power, and so on. So I'm not done finishing the problem. I just want to make sure that I touched on that. I have x by itself now, thanks to the left-hand side. And then I have the cube root of -8. Well, this is just like we talked about in the beginning of this video. The cube root of -8 just means something times itself 3 times. It gives me -8 as an answer. And I know that that would be -2. So that's one way that you could solve algebraically, is to introduce the opposite of the third power. If you want to solve something with a third power, use a third root, the opposite. If this problem said x to the 4th equals something, then you'd use a 4th root. If this problem said x to the 10th equals something, then you'd use a 10th root. So using radicals just means introducing a root in order to cancel the power that you want to get rid of. If that idea makes sense, then you can totally skip ahead to question number 2, skip the next video, and see if you can figure out how to use radicals in question number 2. If this method didn't make sense to you yet, or if you feel like you want to see the other method before you officially decide how to proceed, then tune into the next video and I'll walk you through a slightly different method to see if that sheds some light on things.